So when we're working with parabolas and quadratic functions, an important characteristic is the maximum or the minimum value. We've talked about this a lot, but we're going to formalize this a little bit more today. So knowing the vertex and the direction of a parabola lets us quickly decide whether it has a maximum value or a minimum value. And so when we read and describe a graph, it's important to keep the following information in mind. When we read a graph, we always read a graph from left to right. And we've talked about this when we've talked about increasing and decreasing. We always describe where the graph is increasing or decreasing by its x values because we read a graph from left to right. So it's important to decide based on what the question is asking, do we want x's or do we want y's? So whenever we're talking about x values are always talking about where, and y values are always talking about what. And so that is a general way to categorize. That's how I like to think about it, is that x values are always asking about where, and y values are always asking about what. Okay? And so here's some examples. If it asks you to give the location of the maximum or the x-intercept or something like that, where does the graph have a maximum? When does the graph increase? At what point does the graph blah, blah, blah? Those are all examples of where is something happening. And so that would be asking you for an x value. Now, y values are asking for what does the graph have? So those would be things like find the value of the maximum, find the maximum value, find the minimum value, evaluate the function. So that would be also things like find f of x. What is the value of the function? Those are always talking about y values, okay? So what I want you to do is take a moment to pause the video, and I want you to read each of these statements, okay? And I want you to decide, is this a question that would require an x value of a graph or a y value of a graph? And so use those examples up above to help you decide, are we looking for an x value or are we looking for a y value? So pause and take a moment to think about these on your own. All right, so at what point does the graph have a minimum? That is asking for a location. It's not asking what the minimum is. That's asking where does it occur? At what point? So this would be an x value that it's asking for. Where is the graph increasing? We've seen that question several times. That's a location. That's asking for an x value. Find the maximum value of the function. That's asking what is it? That one would be asking for a y value. We want to actually know what it's equal to. When does the function reach a maximum value? That's the same thing as asking where. So that one is going to be asking for an x value. And then it says determine the absolute minimum of the function. That means the minimum value of the function. What is the minimum of the function? That one would be asking for a y value. So this is one of those examples where it really hits home that math is a language. We have to be able to read and interpret and understand that language of mathematics so we know how to interpret the question and know how to correctly answer that question. Okay, so for a quadratic function, now we're going to mostly focus on standard form today, but this is going to be true for all forms, whether it's intercept form, standard form, vertex form, anything at all. For the quadratic function, the y-coordinate of the vertex is the minimum value of the function when a is greater than 0, and it's the maximum value when a is less than 0. Which again, that makes sense because when the graph opens up, the vertex is at the bottom, and when it opens down, then the vertex is at the top. So the y-coordinate is what the maximum or the minimum is equal to, and the x-coordinate is where it happens, okay? So the answer to a maximum or minimum question will always come from the vertex, no matter what form of the function you're given. And then remember that if it says where is the maximum or minimum, that means give the location, which is the x value. What is the maximum or minimum means give the y value of the vertex. Okay, so number 11 says, find the minimum or maximum value of the function f of x, give the domain and range of the parabola, and tell where the function is increasing or decreasing. So it says find the minimum or maximum value, meaning what is it equal to? That's a y value. We're looking for the y coordinate, okay? Maxes and mins always come from the vertex. So the first question is, does this parabola open up or down? Since A is positive, this parabola opens up. So if it opens up, the graph looks like this. We are looking for a minimum because the vertex is going to be at the bottom of the graph. So what we have to do first is find the y coordinate of the vertex. So we're going to use our formula to find the axis of symmetry, x equals opposite b over 2a. So the opposite of b is going to be positive 2 over 2 times a, which is 1/2. So that's going to be 2 over 1, which is 2. Then we want f of 2, which is going to be 1/2 times 2 squared minus 2 times 2 minus 1. So 2 squared is 4, minus 4 minus 1. Half of 4 is 2, minus 4 minus 1, so that gives us -3. So our vertex is 2, -3. All right, so the minimum value is f of x equals -3. Okay, now no bald answers, meaning whenever we're talking about a function or a graph, we should never just be giving a number like -3. It should either be x equals or f of x equals. That's how you're very clear. Is it a y value? Is it an x value? This is a function value, which is the y value, because we're asking for the minimum value. So that's why I include the f of x equals. Never give a bald answer. So it's either an x or it's an f of x. You got to pick one. Commit. The minimum value is f of x equals -3. Now, domain and range. The domain is all real numbers. The range, since this parabola opens up, it's going to be y is greater than or equal to -3. Where is it increasing and decreasing? Again, think about this picture. Since it opens up, it decreases first, and then it increases. And remember, that always changes at the axis of symmetry. So it's going to decrease when x is less than 2, and increase when x is greater than 2. This graph, what's the vertex? 2, -3. It looks like something like this. Okay, so this is at x equals 2. It decreases and then it increases. So that's what we have. Okay, pause your video, try the same thing for number 12. I'll come back with the answer in about 2 seconds. Okay, first thing is there's a typo there. That should say locate the maximum or minimum value. Now this is another one that since it opens up, this one has a minimum. And since this one says locate, the question is asking where does it happen? So it wants the x value for the answer. And so using that same formula, -b over 2a, we get that x is equal to -2. So that answers the question. There is a minimum at x equals -2. Now, if it asked for what it was, we would say there is a minimum value of f of x equals -19, but that's not what it asked. It just wanted to know, where is it? It happens at x equals -2. Now, we did need that function value to be able to figure out the range. So that's why I did f of -2, which is -19. So the vertex is -2, -19. I needed that to be able to figure out the range. And so that's how we get the rest of that information. So that is a little bit of background on maxes and mins. Okay, it depends on whether it opens up or down, whether it's a maximum or a minimum. And you have to be careful about deciding, is it an X value or a Y value? But that is the main idea with maximum and minimum values.